All right, next let's look at question 3. So question 3 says perform addition or subtraction and use fundamental identities to simplify. There's more than one correct form of the answer. So question 3 kind of has a similar feel to it as both parts of question 2. And looking at this expression, there might be a couple ways you would think to go about it. My thought was to take a common denominator and simplify that difference of two fractions to 1. So what I did was, my first step was to take a common denominator. And now just sort of, trying to guess other things that you might have thought to try. So maybe you thought to try replacing all the secants with 1 over cosine. And that's a strategy that works very often, is to reduce all of the expressions to just sines and cosines. In this case, I didn't do that. And the reason that I didn't do that was actually like thinking a few steps ahead. And because I realized that if I did take a common denominator, I would get this nice expression on the top where things would cancel out. So the two secants would cancel out. So kind of my strategy here was informed by me looking ahead and kind of preempting what was going to happen. And so now that numerator simplifies really nicely to just -2. But along the way, we've also got our denominator. So once we multiply those two factors, it simplifies down to secant square x, which is good for us because we have the Pythagorean identities, and for instance, it gives us that 1 plus tan square x equals secant square x, which is going to imply that secant square x minus 1 is tan square x. So once I multiply those factors out, I get something that actually simplifies very nicely. And this is by Pythagorean identities. And that's kind of where I leave it with this answer. It seems pretty simple to me at this point, and I'm happy with that. But again, maybe you think to rewrite that as -2 cotangent square. There's a couple directions you could go further, but I'm pretty happy with it, and I'm leaving it there for now.